It's weird. Oh, okay. I was wondering why I wasn't seeing my bottom bar. Figured something was blocking it, but I wasn't sure which. Okay, so we'll come over here and go ahead and close that. Then I'll do a file, new project. And I'll call this Math Fun. Oops, not there though. Java application, Math Fun here. Okay, so go down to this package right here, Kali.mathfun. Right click on that, choose new, JFrame form, and I call this main form. And click finish. Now, chapter 6 is this week. Chapter 6 is about value methods. Now, I'm going to cover these, but I'm going to cover them a little bit differently. Value methods is instead of void, you're returning something. For example, we've seen where you just call a method and it's void and nothing's returned. We've also used some methods where you do have stuff returned, like math.abs. That returns the absolute value of whatever's inside the parentheses. Well, we're going to be writing our own. Demonstrating all the concepts dealing with this. So I'm going to come over here, Kali Math Fun, and I'm going to right click and I'm going to choose new and I'm going to choose Java class. And I'm going to work with fractions. So I'll call it fractions and click finish. And it'll create, in that package, it'll create a public class fractions. Now, if you go over to w3schools.com, they have a section called Java classes down here, and then Java object-oriented programming. And then here's where it actually starts defining the different items. And public class, my class. Public class, fractions. That's just how you define a class. So that's the beginning part right here. We're going to see how to create an instance of it here shortly. Okay, but first, it says public class attributes. These are items that you define. What makes sense with whatever you're working with. They have my class, they have X and Y. On mine, it probably makes sense that I have numerator and denominator. Now notice that over here, they actually assign it equal to a default value. So int numerator equals 1 to begin with, and int denominator equal to 1. Now back to my main form here. I'm going to start off by writing a program that will simplify a fraction. So they're going to put in a fraction, and then I'll click a button, and then it'll reduce the fraction. Like 5/10 would go to 1/2. Okay, so I need some text boxes on here. They're there. Text fields, I guess they're called. And another text field. Labels. And a button. And a label. Label. And I'm gonna do this a little bit different. I'm gonna delete this label here. Mainly because I'm pretty sure we'll get far enough where we'll start adding fractions, subtracting fractions, multiplying fractions, and so forth. Okay. I'll drop a separator on here. There we go. I want that kind of separator. Nah, I don't want that. I'll just put a label on there with the dashes. Okay, that's weird. I hate how it bounces things around. It takes a little while. Okay, so I'm going to copy that. I right-clicked on it. I'll paste it down here. There we go. And give this some kind of text. I'll call this fraction 1. Give this a name. Get rid of the text on it. I guess I can right-click on them, edit text, backspace. I'll call this one right-click, change variable name. I'll call it TF underscore numerator. Right-click on this one, and I'll say change variable name. I'll call it TF underscore denominator. And right-click on this one, say edit text, and this will be simplify. You want to simplify that fraction. This will be my answer. So I'll right-click on this, and I'll say change variable name, answer underscore numerator. Actually, it's a label. So we do LB underscore answer numerator. This one I'll right-click, change variable name, LB underscore answer denominator. Right-click on that, choose events, mouse click. Okay. Well, we need to bring in those two values, and I'm going to change them to integer. So I need numerator, denominator. Numerator is going to equal to integer dot parse int. And I'm going to call it TF underscore numerator. Denominator is going to equal to integer. The TF numerator is not correct though. Let's get text. Integer parse int TF underscore denominator dot get text. I don't remember if it should be a two-string though. We'll try that first. Might have to put a two-string on there. I don't remember. Get text. Some languages you do have to put the two strings. When you do a get text, it returns as a string. Okay. Now we want to create a new fraction. So up here, and I shouldn't have called it fractions. That's okay. I wonder if I can change it at this point. If I don't screw it up. Rename. I don't think I ever save as. No save as. Let's go over here. Well, we just change the fraction there and break it. I can really not do a save as. I would expect that he could have changed the name. Oh well. I'll leave it as fractions. Doesn't matter. You'll understand the principle once we get there. Okay, so I declared this class over here called fractions, and I'm declaring a fraction f1. Now down here, I'm going to say f1 is equal to new fractions, beginning parentheses, closing parentheses. This right here creates an instance. So in other words, it creates a new fraction. So it creates a new fraction. And then I come over here, and I'm going to create some gets and sets. So I'll say public void. I might have to put a static on. I don't remember. Probably since it's in the same package, I don't need to. Public void set numerator. And I'll be passing in. I'll say num. And here I'll say numerator is equal to num. Now a set allows us to set the value of the attribute. Public void set denominator. Passing in num. And then denominator is equal to num. This is standard, not just a program we're writing here, but this is standard anytime you do objects. You do classes, you have gets and sets. Sets values, and it's usually, it's all usually a void. I guess it wouldn't have to be. The gets returns a value. So I do a public, and I'm going to return a numerator, which is an integer. And then I'm going to say get numerator. I'm not passing any parameters. And all that does is simply do a return on numerator. And I'll do a public int on get denominator. And then I'll return the denominator. So if I come over to my main form here, I'm going to get those, and I'm immediately after I create that, I'm going to set them equal. So I'll say f1 dot set denominator. That's nice. F1 dot set denominator. And I'll do a beginning parentheses, and then I'll be passing in denominator. That's the variable I got declared here. And this is set in the class variable, the attribute, class attribute. And then I'll do a f1.set numerator. And I'll be passing in numerator. So again, that's the variable I declared right here. And this is going to be setting the class variable or class attribute, called by different names. Now I want to print those. So I need to have a string, I guess. String. No, I don't want a string. I'm going to put it back out in the format I originally started building my program in. So that was LB underscore answer underscore numerator, I think it was, dot set text. And then I'll be passing in string dot value of, and I'm going to say f1 dot get denominator or numerator. Okay, so then LB answer denominator dot set text string dot value of f1 dot get denominator. Okay, so if I run that in main form, that'd be good. Then I put 5 in here, put 10 in here. And I click simplify, it gives me 5/10. So nothing exciting, just transferred it. But it does show you that I declared a class over here, an object, fractions. Then said fractions f1, I declared that. And then I have my numerator and denominator here. I bring those in. I then create an instance of that object. We're going to see soon that I can create 2 instances, or however many. I issue sets to set the denominator and numerator. And then over here, I return those values by doing a get numerator and get denominator. And those are calling these methods over here. Oops, over here. So those are calling these methods here. And they're returning values. Okay, now what I want to do is I want to simplify. So I come down here before your last curly brace, and I'm going to say public fractions and simplify. Okay, so then I'm going to fractions reduced frac. And then now where I'm going to be calling this from is I'll be calling it from that particular fraction. And so I'll have access automatically to these attributes up here, these class variables. So I don't have to refer to them. But I am going to need to set these and then handle it appropriately. Now, just in case it doesn't simplify at all, I'm going to go ahead and initially reduce fraction dot numerator equals numerator. I might have to put a this. I don't remember. Verb might not have been initialized. Oh, because I didn't do a new. Reduced. Why am I making that so hard on myself? I'm just call it RD or RF for reduced fraction. That doesn't exactly self-document, but that's okay. So RF equals new fractions and RF numerator, except for I'm forgetting it's a fraction, so I need to call the set denominator. Why do I keep getting that? I know why. When I do this tab, I'm not where I need to be. Set numerator, and then I'll say just numerator. I'm accessing the class variable directly, a class attribute. Then I'll say rf.set denominator. Denominator. I'll set that equal to denominator. Okay, so then I'm going to have a for loop for int x equals, and I'm going to start with the numerator. I'm going to continue when x is greater than or equal to 2. And I'm going to say x equals x minus 1. And then I'm going to have an if statement here. I don't need those braces, I don't think, but I'm going to say if RF dot get denominator percent x equals 0 and RF dot get numerator percent x is equal to 0. That means that the number divides into both of them. That's a modulus operator. So I'll say RF dot set denominator, and I'll do RF dot get denominator divided by x. And RF dot set numerator, then RF dot get numerator divided by x. And then down here, I want to return RF. Okay. That should work, but we'll see. So over here in my main form then, I want to create a new fraction. I'll call it my answer frac. And I want to create a new instance of it, so I might as well do that here with all the other new instances. Answer frac is equal to new fractions. And down here, answer frac is equal to, and then f1 dot, and you see there's now a simplify. Okay, so if I put that in the wrong place, it'll be right there, so I can write up my answer. So answer frac and answer frac. And let me save that. Now run. Then I'll explain it. if it works. Doesn't do any good to explain it if it doesn't work. Let's see, 20 over 24. And it blew up. What did I do wrong? Uncompilable. Variable get denominator. Location RF of type. Of course, because they're methods. And with methods, you have to have parentheses. Why didn't give me a little red squigglies on that, though? Try to. Okay, 20 and 24. And both of those are divisible by 4. 20 divided by 4 is 5. 24 divided by 4 is 6. Okay. So this is creating a new fraction. This is also creating a new fraction. This sets the denominator of F1 and numerator of F1. This calls, based upon F1, that numerator and denominator that I set, this calls simplify. Now, when it calls simplify, it comes over here, and it creates a brand new fraction we're going to return, because it's going to return a simplified fraction, so it doesn't destroy our original fraction. It could, but this is set up so it wouldn't. And it automatically sets the numerator and denominator to the default of whatever is passed in. What's passed in is this here in front. By doing this association, it's passing in all the class variables and class attributes with of fractions, specifically of F1. Then down here, this is like when you're simplifying a fraction. If you have 20 over 24, for example, you think the largest number divides into both of those. Well, programming-wise, you can't really come up with that. Not unless there's some math library that does that. So what we do is we start with any of the numbers, numerator, denominator, doesn't matter what you start with, your choice. I chose to start with the numerator. And then we're going to check to see if both of them are divisible by that. Like if I check 20, and I say, okay, 20 is divisible by 20, but 24 isn't. Divisible means you don't have a remainder, you don't have any decimals if you put in your calculator. So then I want to go to the next number down. And that's why I do the x equals x minus 1. It'll go to 19. It says, hey, they both divide by 19. No, then 18, then 17, then 16, and it keeps on going down until 4. And 20 divided by 4 is 5 with the remainder of 0. 24 divided by 4 is 6 with the remainder of 0. Since both those give me a remainder of 0, that's what this check is doing. Then I go ahead and I divide each one of those numbers by that. And in actuality, you could break at that point, but if I put in something bigger in here, click simplify. It'll take a little while. I don't think it'd take that long. Did I click the simplify button? Okay, maybe too big. 20,000 shouldn't be that long in a loop. Just double check. Could be something else wrong with my code there. Let's try it again. 200 over 408, I think it was. And let's just, it just works. Not creating a new instance each time. I don't know why I done it the first time. So it doesn't matter, it'll simplify the fraction. After it finds the first one when decreasing, it could stop right there in actuality. Okay, one more. I'm not gonna get as far as I wanted today. I'm gonna show you adding fractions. Mainly because I want to go away from a math example and give you an example of what I'm looking for you to create on your own. Okay, so go to my fractions, and I'm going to be adding fractions. So like I'll add one fraction to another fraction. Now there's different ways you could handle that. And how do I want to handle it? Public. If I just did a void, that would be where you're taking one fraction and adding it to the one you're referencing to. But maybe I want to add two fractions and return it to a third fraction. So that's where you have to really think about what you're going to return. Add, and I'll be passing in. Let me think this through. Okay, yeah. So I'll be passing in a fraction, f1 and f2. Now, if you knew the shortcut for fractions, the shortcut for it is where you take a times d plus b times c, and you divide it by bd, and then you simplify it. It's like 1/3 plus 2/5. You take the number on top here, multiply times this denominator, plus number on top here times this denominator, and then multiply denominators together. So pretty simple idea on that. So I'm going to say, since I'm referring to a particular fraction here, I'm going to say that my numerator is going to equal to, think about this, A. A is the numerator of my first fraction. So F1 numerator times B. B is my, what's my B? D. It's D. What am I talking about? D is my denominator of my second fraction. So F2 dot denominator plus B, which is the denominator of the first, so F1 denominator. Don't worry about this. If you're not into math, if you're into math, you're probably enjoying it. Not many people are into math. It's a numerator. Okay, and I don't need those parentheses there. What am I doing here? There. In my denominator. Denominator is equal to B times D. B is the denominator of the first, so F1 denominator times D, which is the F2 denominator. It doesn't like something. Missing return. Oh, because I'm returning a fraction. Do I want to return a fraction? I don't think so. I think I want to void. And I'll explain why. So you can see the difference. Okay. So over here in our main form, I need another fraction. So fraction 2 and text field Another text field. Copy that, paste that. Right click on that, edit text, get rid of that. Size it. This will be change variable name TF underscore numerator 2. This one, edit text, get rid of that, backspace, enter. Right click on that, change variable name TF underscore numerator denominator. Bad programming. Denominator 2. When I gotta have a new button here, so when I click the button, it'll add these two fractions together and print the result in my answer there. So I need a button. And right click on that, change edit text and add. And double click that. Okay. So I'm going to have fractions, and I'll be bringing in one fraction. I'll call it F1. I'll be bringing the other one F2, and I'll have an answer. F1 is equal to new fractions. F2 is equal to new fractions. Answer is equal to new fractions. So create all my instances of my object. And F1 dot set numerator. And see, this is going to be an integer, so I need integer dot parse int. And this will be TF underscore numerator dot get text. Then F1 dot set denominator. Integer dot parse int. TF denominator dot get text. And then F2 dot set numerator. Integer dot parse int. TF underscore numerator 2 dot get text. And F2 dot set denominator. Integer dot parse int. TF denominator 2 dot get text. Okay, so answer dot and then add. Now I'll be passing in F1 and F2. Now I named those the same, but they don't have to be named the same as the object. Okay. So what this is going to do then, this is associated with my answer fraction. It'll pass these two in as parameters. It'll call this right here. It doesn't return anything because it's set in the numerator and denominator of that instance directly. So I don't have to actually return it. Now I do need to print out my result now. So I'll say LB underscore save a little bit of time. LB underscore answer numerator is equal to my answer. Get the numerator and answer, get denominator. Now for to run that. I put 1/3 in here and I put 1/2 in here. That gives me 2/6 plus 3/6 is 5/6 if it's working. It gives me 5/6. Now it does have a problem because if I had a 2/10 and 3/10. That would add up together and give me 5/10, which reduces. But that doesn't do it here. So what I have to do is I'm going to have to simplify that fraction. Well, that's not too hard. Except my simplify is working such it doesn't work on the current instance. The simplify returns a fraction because I didn't want to modify the original. So it's easy to fix though. You just say answer is equal to answer dot simplify. And now if I run that, if I put in 2/10 and I put in 3/10 and click add, 2/10 plus 3/10 is 5/10, which reduces to 1/2. So it'll automatically do that. Now I'd probably go ahead and do some of these other ones. They're easy. Once you have the basic framework in place. If I change this and I have a subtract. The difference on that is that this is a minus here. So I simply just change this to a minus. Now multiply. And multiply would be to take, let me think this through, a times c, multiply your numerators together, divided by, multiply your denominators together, b times d. Okay, so this should be multiply, what did I say, my numerators, so this should be numerator. And multiply my denominators. So if I'm all messed up. Numerator is that, denominators multiplied together. So numerators multiplied together, denominators multiplied together. Okay, I think that's right. Famous last words. And divide. And divide. I flip my second fraction, so it becomes d over c, so I multiply a times d, and this would be b times c. So numerator here times the denominator there, yeah. On this one, this would be the denominator b times the numerator. Okay, so now I need some buttons. This will be my subtract. This will be my multiply. I'm right clicking on it there. Multiply, I need my divide. Okay, so okay, so that's my add. And instead of calling add, I'm going to call subtract. multiply. And didn't like something. Got to change it in the right place. Multiply. Okay, then divide. Okay, so let's try it now. Now I'm going to check, do something I can check. 3/10 minus 1/10 gives me 2/10 or 1/5. So subtract those. 1/5, that's working correctly. If I multiply these, that should be 3 over 100. It is, but how about if I want something I can simplify, like 30 over 100? That goes to 3/10. Now dividing. If I put a 20, what do I put a 20? I gotta flip this. So I want this to be like 9, and this to be 20. When I flip that, that'd be 20 over 9, so it should give me 2 over 3, I think. It does. Okay, so those are all working. Now this shows you the power. A lot of what you were seeing me do very, very quickly was just edit, copying, and changing one item. This shows you the power of designing a class. Now I got a class. If I save this off, I could incorporate this into every program I wanted to and never write this code again. I got it working. It's perfect. I'd maybe add mixed numbers in there and I'd be done. I'd never have to worry about it the rest of my life. Okay. Let me close that. And I'll show you what I want you to do in the project. I don't want you to do math unless you just love math, and fantastic. But you choose your own setup, whatever that might be. I'll choose, I don't want to choose that. What am I doing? Java, Maven, Java application, next. The human project. I click finish. And over here, my source package, I'm going to right click on the package here, and I'll choose JFrame and give it whatever name. I also want to come over here, right click, and I'm going to choose new, and I'm going to choose Java class, and I'm going to define a human, and click finish. Now I want class attributes to go with a human. Human can have a name, let's say a first name, and I should initialize those. It can have a last name. Human can have an age. I call that int. Now I want to come up with my returns or my gets and sets. So I'm going to have a public void set f name, and I'll be passing in fn for the parameter, and I'll say f name equals fn. Now I want you to choose whatever you want. Don't do human. Do some other object, record, car, whatever floats your boat. Then do that. ln, and then lname equals ln. You notice these are all public voids. They're all set, and then whatever my class variable, class attribute is called. And what's this? It's going to be an integer. Age. Don't make it the same name. You could, but you have to do something different. Page, I'll say age is equal to p underscore age. Okay, those are all our sets and sets. So we need our gets. So get, you put in your public and then the data type. So if I return the first name, I have to do a string. Get F name, and this will just be return, I think I called it F name, public string get last name, and return L name. Now I'm going through this kind of fast, but this is the exact same code in all these, if you've noticed. Now here, though, getting the age is an integer, so I have to make sure that data type there is int. Get age. And then return age. Okay. Now over here in my, this right here, I'm going to ask the user, and so I'll have a text field, I'm going to ask them for their first name, last name, and age. So whatever class attributes you have declared over there, class variables, then you want to get it from the user here so you can set it with your program. So I right-click on this, edit text. This will be my first name. Right-click on this, say edit text. This will be my last name. Right-click on this one, edit text. This will be my age. Right-click on that, edit text, backspace. Make it big again. Right-click on this one, edit text, backspace. Right-click on this one, edit text, backspace. I know there's some kind of pattern to why it resizes. I just haven't cared enough to actually read up on it. Mainly because it's not that big of a deal for me just to resize them. Okay. And then down my button down here. There. And I'm going to right-click on that, and I call it create human. I'm going to create a human. Okay, so if I right-click on that and choose events, mouse clicked. I created a class, an object called human. So I'll declare a human. I'll call it David. And I've created an instance of it. David is equal to new human. That. And I want to set David's first name. So I'll do David dot set first name. David dot set last name, L name, Hayes. And David dot set age, and 54. Okay, so I've created a new human called David, and I've set the class attributes, the class variables of F name, L name, and age. Now, at that point, I want to do something with it, so I'll write it back out to the screen here. And that's what I want you to do, is I want you to write it back out to the screen. Not do anything more exciting than that. What if that'll say big? Yeah, it is. Okay, so that's going to be my right-click, change variable name, LB underscore result. And here, I'll do LB underscore result dot set text. And I'm going to say David dot get first name. That's going to return a string. And then I'm going to do a plus for concatenation. I think that's concatenation in Java. And David.get last name plus. And here I need to do a string.value of because age is an integer. And I do David.get age. And closing parentheses on the set text. I think that's it. Oh, this is a method I'm calling, so I need the beginning parentheses and closing parentheses. Let's run it and see. It'll be all smacked together. No spaces between them, but that's okay for what I'm showing. Okay, so David Hayes, and then 54, and puts them all together. So this demonstrates creating a class, a new object, doing our gets, and then doing our sets. Let's see. This gives you, read through this. This is kind of interesting. If you want to create a different example, you want to create a geometry example, fantastic. It's entirely up to you. If you want a non-math based example, I've showed you that. Create a human, create a car. What's unique about a car? You got a model, you got a I can't think what else. Make. You got a year, you got a VIN number, so there's a lot of different ones. I want at least 5 class variables. It looks like the example they do is a distance formula. So they work with points and so forth. I talk about method composition. So read the chapter. Overloading we didn't get to. That's where you redefine calculate area in a couple of different ways. We'll eventually get there. Boolean methods, you can return a Boolean. Java doc tags, if you want to do that. Don't worry about the recursion. We'll talk about recursion eventually, but I want you to get used to working with more of the methods and so forth. Okay. So again, the project, you pick what you want. I picked create a human. But you can do whatever you want and do kind of the same setup as what I did here. If you want to go hog wild like I did with the fractions, fantastic. If you don't, I'm fine with this. Questions on the project? Well, I'll go ahead and stop there because I don't think there's anything I can really add to that in 2 minutes time. I could put spaces between those, but